So finally, we have come to the last module of this episode. This is module number 17. Here we deal with another aspect of non-response, highly qualified in terms of research topic, in terms of thought process that is going on, and it started very early when the subject was developing. People tried to understand the sources of non-response, and in that context this topic came up. There is a thorough and disciplined study on this topic over the years, over the last 50-60 years, and I will give you an account of what is going on in this area. So, this is where we talk about non-response techniques. So, as I said, this is the last module in the series of 40 modules that we are trying to cover, various aspects of DOE and sample survey. I would like to dwell on non-response in sample surveys, which is regarded as a major practical problem in actual surveys with human populations. That is the biggest problem. So, let us take up some issues involving non-response. However, I will touch upon some uncommon problems and thoughts. It is generally said that two of the main sources of non-response are refusal to or evasion of answers to questions of a sensitive nature and not at homes. Whenever you are dealing with human populations, first thing could be if it is a sensitive nature. If the issue is of sensitive nature, then of course people might try to refuse giving an answer, or they might give a wrong answer, untruthful answer. These are the typical things that happens. That is why we talked about RRT and other modifications. And other thing is people are not available. So, how do you expect to get response from them either way? Okay? So, we already took up the first issue and deliberated upon some aspects of RRT towards resolving this problem involving sensitive issues. As to the not at home category of individuals, persons or respondents, usually the technique of callbacks is proposed. Callback means you go first stop and then you call again, second call, third call, etc. Early attempts to tackle this type of non-response may be attributed to Yates in 1946, Hansted and Harwich again in 1946, who introduced the methodology for callback procedures. In a way, the population is tacitly divided into two categories or strata. Response stratum, wherein the units they do respond at the very first attempt. They are cooperating with you. You check with them, they are available and they respond and you get the response straight away. And the other is the non-response stratum called the hardcore stratum, in which the units do not respond in the first attempt and also rarely do so in subsequent attempts. Even if they are available, they may not feel like cooperating, and if they are not available in the second attempt, you get them, but still they are reluctant to give information. A second attempt is in order and it is made based on a selection of a subset of the non-respondents. The first time you go, there are certain non-respondents, you make a subset selection, make a second attempt and so on. Deming considered a mathematical model for callbacks dealing with cost consideration as well. You see, all these are 60, 70, 80 years old study.
Sir, yes, we've studied a little bit of this in our sample surveys course. Generally, 2 or 3 attempts are made, recommended to recover a part of the non-responding group. Then the results are mixed together to arrive at estimates of the population proportions, say for example. I'm sure you have a different material to talk about.
Yeah, generally in the textbooks you are told, okay, go for a second attempt, go for a third attempt, make a subset selection, make a disparate attempt to get some of them, and then kind of pool the data, whatever evidence you got right from the first attempt, pull the data together and try to come up with an estimate of either it is a population proportion or population mean, do something with the data. That is the kind of thing that is mentioned in textbooks, for example, Cochrane's book. However, I have got something entirely different to tell. The group of individuals labeled as not at homes are temporarily absent from home. Maybe they are located either at work or on a short holiday or visit. So, Cochrane's textbook describes in detail the callback technique with reference to the number of callbacks and the relative costs that are involved. Naturally, every callback costs money. So, he talks about a number of callbacks and then how the cost is involved and how the precision gets as you continue to go for more and more callbacks. It is interesting to note that Hartley suggested an ingenious alternative to callbacks, which is decidedly cheaper. First time is okay, any time after that as you go ahead and then recall, it is a matter of more and more costs. So, it was Hartley who suggested an ingenious technique, no need to go for callback. Hartley mentions details of this scheme are given to the wartime social survey, but I understand that owing to pressure of work, an opportunity of trying out this thing has not yet arisen. Soon after, Polish and Simmons 1949, they published their work, popularly known as Polish-Simmons technique, in JASA, Journal of American Statistical Association, which is on similar lines to the suggestion of Hartley. So, Polish and Simmons in their paper, while acknowledging the work of Hartley, they mention like this: during the past 3 years, we have developed a plan for eliminating the need for callbacks, and several experiments have been made applying this plan to market surveys. So, you take away with the method of callback, no question of going for callbacks. First time you do, you have the data, based on that you start working out. So, what I propose to do, I want to give you a test of the study that was made by Polish and Simmons, akin to the suggestions that were made by Hartley, and this is now popularly known as Hartley-Polish-Simmons technique, HPS technique or HPS sampling scheme. Okay? Basically, it is a technique. The HPS technique consists of grouping the results, what Hartley calls as strata of the first call, as follows. Assuming that all calls are made at a particular time in the evening of each of the 6 weeknights. Let us try to understand. So, assuming that all the calls are made at a particular time, say 7 o'clock in the evening of each of the 6 weeknights, Monday through Saturday, 6 weeknights, every night around 7 o'clock the calls are being made. They proceed to question the respondent if he or she had been at home at the same time on each of the 5 preceding weeknights. So, we are going to explain all these things.
Sir, please, let us take a stock of what you're saying. As I understand, you're referring to 6 weeknights, Monday night through Saturday night. Suppose the interview is held on Thursday night, more or less 7 p.m., say covering half an hour period. Then whoever is available at that point is asked, were you at home around this time yesterday, meaning Wednesday, Tuesday last, Monday last, Saturday last, Friday last? I believe these are the questions posed, and truthful responses are sought from the respondents in terms of binary response. I can see that there should not be any issue of memory loss for this short time span. This is an interesting approach for sure, so as you said, there is no question of any recall for those not available on this night of the survey.
Yeah, so let us take a review of what you said just now. Imagine the survey is conducted on Thursday night. You pick up this Thursday as a random day out of the 6 weeknights. So, Thursday was picked up at random, and around 7 o'clock you make a call. You have a good manpower covering all the people in the universe, all the households in the population, you make calls. And then all those who are available, you find them, you make a pool of them. Okay? And all those who are not available, there is nothing that you can do. So, you do not go for recall. That means I have made a master list of all those who are present today, okay, let me try tomorrow again. For those who are not available today, no recall, nothing like that. Whatever you got is fine. But in this, you can make a strata. What is the strata? Now, you ask the people, are you at home, now that you are home today, this evening, are you at home yesterday, meaning because it is Thursday, meaning Wednesday, are you at home Tuesday, that means day before yesterday? You make a very clear question as to 1, 2, 3, 4, 5, 6. There are 6 weeknights, this is the night of the survey, so 5 more towards the back. It is Thursday, so you go up to Friday. It says Wednesday, Tuesday, Monday, Saturday, Friday, referring to the last. As you said rightly, there is no question of memory loss because it is a short time span. And even if the individual cannot tell he is in a household, So his family members can tell, yeah, we are home, no, we are not at home, like that. So they can give a truthful response to this. This is the first part. And then you go for asking about your sensitive character and all that. There you play this RRT and all that. But at least you know the status of the people who are present tonight in respect of the immediately past previous 5 nights. That is the whole idea. Okay? At least you have a stratification of these people. So tonight Thursday, then go back Thursday and Wednesday, Thursday and Wednesday and Tuesday, Thursday and Wednesday and Tuesday and Monday, etc. There are 5 of them. So 2 to the power 5 minus 1, 31 possible, 2 to the power 5, 32 possibilities are there. Given that it is on Thursday is yes, Thursday has got a tick mark, the remaining 5, 2 to the power 5 possibilities are there, 32. All no, only today is yes. You understand? Only one of them together with today, only 2 of them together with today, and so on. So there are 32 categories based on the simple call that you are making here. That is the idea. It is an interesting approach, as you said, for sure. There is no question of any recall for those not available on the night of the survey. Okay? But you already got massive amount of data. So I appreciate your approach that at times it is worth taking a stock of the material that is being discussed. Okay? Now we have perfect idea about what is the basic data that we have collected through stratification. Let me now proceed. Imagine a situation wherein we have a total of capital N households in the neighborhood, and we conduct 100% screening, that is census of the households, on a randomly chosen weeknight. So this Thursday, as you said, that has been randomly chosen, and on Thursday we are making 100% screening of all the households. So we have massive manpower to make a phone call around 7 o'clock in the evening. That we are doing 100%. But something is unavailable, that is what we call N0. N0 is the number of households reported as unavailable. Why do I write N0 tilde? That is because you are referring to a random day. Today I look at 1000 individuals, today 700 individuals are not available at home. But that is referring only to today means the day of the survey. That is why I am putting N0 tilde. N0 tilde be the number of households reported as unavailable. Further, let Ni tilde be the number of persons or contacts among the households who report as being at home on exactly I nights, including the night of the survey. I equal to 1, 2, 3, 4, 5, 6. Okay? So the capital N, the total number, 1000 individuals, households in this neighborhood, that 1000 has a breakup. These are the stratified numbers. How many are present in exactly 1 night, exactly 2 nights, exactly etc. up to 6, and that is the number which was unavailable today. Because they are unavailable today, I do not know their status on other days. Simply today they are not available. Further to this, note that if N0 tilde is positive, that means at least some people are not, they have not shown up today, they have not responded today. If that is the case, then N60 equal to 0. There cannot be people who are present on all 6 nights, because tonight they did not show up. Okay. On the other hand, if N0 tilde equal to 0, everybody showed up today, that does not mean that they will show up on all the 6 days. So N tilde 6 is greater than or equal to 0, it cannot be strictly positive, I have no idea. Everybody has shown up today. That does not mean they are present on all days. Again, if I is the number of nights the person was present at home out of tonight and the present previous 5 nights, I by 6 is an estimate of the probability of the individual being at home at this time on a randomly chosen night. Let us see. Let us look at the class of people who say that yes, I am present on I nights. Out of 6, I am present on I nights. Then on a randomly chosen night, the chance that the person will be available is I over 6. You can see the inclusion probability of the individual. In an immediately following paper, Polly and Simmons, they discuss the difference in the effects of clustering or stratification in using the nights at home plan. This is the nights at home plan. So all that they did, they made extensive phone call, 100% coverage. Definitely some of them are not available, that we are calling N0 tilde, because it is based on a randomly chosen weeknight, night of the survey. That is why it is N0 tilde, not available. Do not go after them. Whoever is available, make this question. Have you been here yesterday, etc., etc. Yes, no. You get the 2 to the power 5 branching, and that along with tonight you get N0, N1 tilde, N2 tilde, N6 tilde. That is your data. Noting that the first call answers are mostly from those persons who are at home most of the time, the response is given a weight inversely proportional to I. This is what using basically the Horvitz-Thompson estimator concept. So, if it is I over 6, you give the weight 6 over I, that is the idea. So, capital N I tilde over capital N, it serves as an estimate of Pi times I over 6. So, that an estimate of Pi is given by 6 times Ni tilde over I times capital N I equal to 1 top to 6. Let me try to explain what is the meaning of Pi tilde. The proportion of individuals who are present on I weeknights out of 6. My data refers to N0 tilde, N1 tilde, N2 tilde, N6 tilde. That was my delta, giving the identity capital N equal to this sum. From there, I am trying to elicit information on each of these Pi's. So, Pi tilde, Pi means what is the proportion of individuals who are present exactly on I nights. That cannot be simply Ni tilde by N, because it was a randomly selected day. That is why you give this factor 6 over I. I over 6 is the chance of the person being at home, and therefore, you take the reciprocal 6 Ni tilde over I n. Once these Pi's have been estimated for I equal to 1 top to 6, an estimate of P0 is derived from the identity 1 equal to this total. That gives you an estimate of P0. Remember, P0 is not N0 tilde. N0 tilde is all those who are not available today. That includes people who are available on other days. Okay? So, P0 is basically means all those who are not available at all. That number you do not get by from today's survey. Today's survey N0 tilde, it involves P0 component plus something more, and that is what is exactly mentioned here. This is the expression for N0 tilde over N serves as an unbiased estimate for a large number of terms. P0 who are never available. P1, 5/6 of P1. P1 is all those who are available on one day, and 5 over 6 is the chance of no show on a randomly chosen day. So, 5 over 6, similarly 4 over 6 P2, 3 over 6 P3 and so on. So, N0 tilde by N, it serves as an estimate for this quantity, that is for, now you simplify this. From this again P0 can be estimated. So, you look at N0 tilde over capital N, from that you take out estimates of all these quantities and you get an estimate of P0. That is one way of doing it. Other way of doing it is looking at all the Pi hats and then subtracting from 1. That gives you P0 hat. So, you have got two expressions for that. The question comes, are the two estimates of P0 hat necessarily equal? Can any one or both be negative at times? This is something that one should think a little bit.
Sir, this seems to be a highly interesting scenario. Up front, it looks like we're going for a census of all the households, but yet we are in a position only to provide estimates of different meaningful parameters. What if indeed we took up a sample, say simple random sampling without replacement of households? Let me try to figure it out myself. Naturally, we would have a split of small n as n0 tilde, n1 tilde, and so on to n6 tilde, in the same spirit as that of capital N described above. Oh, I see this is now in the framework of two-stage expectation, etc. I believe with reference to the same randomly sampled weeknight of the survey, we can claim expectation 2 of n naught curl.
You are conversant with E1, E2, V1, E2, V1, V2, E1 operator. This is the operator coming in two-stage sampling. Okay, E2 is the conditional.
Conditional expectation of n naught tilde divided by n,
right,
which is n naught tilde divided by n. And hence expectation of n naught tilde divided by n is equal to the expectation of
E1,
conditional
E2, naturally, yeah,
which equals P0 plus 5P1 and
etc.
Likewise, expectation of ni tilde divided by n is Pi times I by 6
Right.
for all I 1 to 6. We are now in a position to estimate the population proportions in different categories as usual.
Yeah, whatever we are doing involving capital Ni tilde and capital N, same thing we do with small Ni tilde and small n. So, all it says is that right on the day of the survey, don't go for 100% attempt to contact all the individuals, make a subset. That is what it says. Take a subset of small n out of capital N. Look only for those households and then see if some of them are available, how many times, etc. So you make a breakup of small n into n0 tilde, n1 tilde, n2 tilde, etc. and do a similar analysis. Let us work out an illustrative example to understand the nature of data and the underlying computations.
Sir, if you don't mind, let me take it up in my own way.
Okay.
Case 1. 100% sampling for a population of 1,000 households yields n naught tilde as 800, and 1 tilde as 40, and 2 tilde as 80, and 3 tilde as 50, and 4 tilde as 20, and then 5 tilde as 10.
Subro, can you stop for a moment? I want to ask you a question. Did you anticipate that if there are 1,000 households in this locality, and if we made an attempt on randomly chosen Thursday night at 7 o'clock, I would expect 800 people not responding because they are not at home? Did you expect that? Is it not too much, or what do you think?
So I think it's too much.
Yeah, that is the impression that I had in the beginning when I was studying the article. Afterwards I realized this is just a fair number, even though to start with it seems too much. Maybe I thought that they are cooking up the figure, or maybe they are doing something wrong. Maybe it should have been 100, 200 like that. But there is a good reason for this 800. So we should not feel alarmed by looking at this figure. Okay? And the rest are quite believable, 40, 50, etc. Okay. And we apply the formulae. So what is your P1? 24%, estimate of P1. So what is the percentage of people who are present just on 1 out of 6 weeknights? 24%. That makes sense. P2 again 24%, P3 10%, P4 3%, P5 0.01%, and finally P0 38%. That is believable. That 800 was giving the impression that 80%. Yeah, 80% no show, but that covers people who are present on other days, not today. And this N0 means never ever. Okay? That is why this P0 that refers to no show at all, never ever they are present. That is up to 40%. 40% people are never available. That is the whole idea.
Again, alternatively, we can compute P naught tilde from the relation before.
Yeah, right.
This gives the impression that both formulae may lead to the same result. Again, we will have similar results while dealing with a random sample of households. It is interesting to note that although hardly 40% are not at all at homes, the survey indicates 80% non-response on the night of the survey.
Yeah, that's kind of paradoxical. Huh? Oh my God, 80% not available. Then how do I conduct the survey? But as a matter of fact, only 40% are totally not available. Okay? That's interesting aspect. So far, we have discussed about estimates of the PIs based on this HPS, Horvitz, Polish-Simon scheme and the data gathering scheme that we had. Suppose we are interested in the incidence proportion PA of a qualitative feature capital A in the population as a whole. How many are drug addicts? For example, how many are smokers? We know we are talking about what percentage are available. Now we want to know how many are smokers, what percentage, like that. Under 100% inspection of the households on a randomly chosen weekday evening, we end up with so many households who are present, and accordingly we can collect binary response data on this item of inquiry from each of these households who are present. Okay? Suppose that it is a regular feature, then there is no problem in getting information on yes, no from these people. But that does not in any way tell you what is happening to the N0 tilde who are not available. The incidence proportion of this feature among n minus N0 tilde households can be computed outright. Because these are the individuals who are present tonight, therefore I can always compute their incidence pattern, PA, how many are possessing the attribute, etc., everything can be done. This does not represent the whole picture, since the nature of incidence of this feature among the remaining N0 tilde households is totally unknown. But we can have a projection. Can we develop a reasonable approach towards estimation of PA at this stage? That is what we have tried to understand. Recall that towards unbiased estimation of PIs, the available households have been stratified or classified according to the number of weekday evenings they spent at home. This number varies between 1 to 6 for each such stratum of households, and for the specific feature A, we can compute n tilde A, number of households possessing the feature A. Note that n tilde A 1 all the way up to 6, this stands for all the households possessing the feature A among n minus n tilde households who are present on this evening. What is not known is the corresponding number among the n0 tilde no-show households. So, now we can project it. However, from our understanding about the data analysis, we know about possible decomposition of n0 tilde among different strata. You recall that n0 tilde has a decomposition. This is absolutely no-show, n0 tilde 0, no show at all. Others are, not today, but they are present on one night, they are present on 2 nights, they are present on 6 nights, where n0 tilde 0 is estimated number of households who belong to the no-show category. Likewise, n0 tilde 1 is the estimated number of households among n0 tilde households who are likely to belong to the stratum 1 and so on. We now project ni tilde A based on ni tilde households for the stratum I. So, all I am doing is I am looking to the incidence proportion of all those households in the category I in respect of the category, in respect of the feature A, and that proportion I am projecting to all those who are present today belonging to the category I, and the projected number of those who are not available today, but still belonging to the category I. So, to that I project this proportion and I come up with a larger number. To summarize, we have gathered idea about the splitting of capital N into 7 categories: no show at all, presence in exactly 1 weekday evening, exactly 2 weekday evenings, and so on. Further to this, with respect to possession of the feature, we have understanding about the number of households possessing this feature in each of the 6 stratum, except the stratum representing no show. The only problem left was to gather information about the possession of the feature A among no show households. At this stage, we have available a number of methods we can use. So, all we have done everything except for n0 tilde 0, that we do not know how many of them belong to the category A. But we have information on other categories at this moment. We can develop a suitable probability model, apply it on the available data. Let us take up an illustrative example.
So, may I continue with the example we had taken up earlier? We had adopted 100% sampling for a population of 1,000 households, which yielded n naught tilde as 800, n1 tilde as 40, and so on.
Right.
Subsequently, we derived P1 had 24%, P2 had 24%, P3 had 10%,
etc.
Eventually, we obtained P naught tilde as 0.378.
Okay.
Now, we introduce a qualitative feature, A, and obtain frequency counts.
Okay.
Total feature count of incidence of A among the n minus n naught tilde households is 60.
That information is now available. But these 200 households, they are available. We talk to each one of them and make a request for whether they possess the feature A or not, which is otherwise taken to be regular. They will say yes, no, I got a total count of 60. That we can understand. And then
what is not known at this stage is the frequency count of incidence of A among n naught tilde, 8 is equal to 800 households, not available on the evening of the survey.
Okay, so that is the issue. I know these 200 people, they are available on 1 night, 2 nights, 3 nights, up to 6 nights. So, their information is known. Not only I know the total 60, I know every category wise, stratum wise I know, giving a total of 60. That is what is written here. We have available decomposition of the total count 60 as follows. What does it mean? There are 20 in the category 1 who say that yes, we possess the attribute A. There are 20 in category 2, there are 30 in category 2 who say yes, we possess the category A. Like that, this total is 60. Okay, that 60 count, we have the stratum wise information is available. And because n0 tilde is positive, so there is nobody who is present on all the 6 nights, that is why n tilde 6 is 0. And then
now recall that n naught
that is the decomposition of n0 tilde.
Is this sum where n naught tilde naught 0 is the estimated number of households who belong to the no-show category. Using the pi hats, we project and compute these values for the n naught 1, 2, 3, and so on.
So the whole idea is N0 tilde is the no-show today, no-show number today on the night of the survey. But I know what are the percentages in different classes, so I project that and get into the splitting of N0 into different components. And to that we apply this percentage that we have found. The percentages that we have found, we apply that and we project these numbers. That is what has been done. Projection of Ni tilde A on the whole population, the adjustment factor that I said, 20 out of 40, but I know it is not just 40, 40 plus a big chunk out of that 800 coming on projected for one night, that is 192. So that is why it is projected to 116, 102, etc. I know 1, 2, 3, 4, 5, this is 0. All I am wanting is cell category 0. That is the one that I want. Summarization of the data, cell category 0, projected cell count 302, out of 1000, I do not know what is the projected count of A, because they are never showing up. For everybody else, I know the number. I know what is the projected cell count, I know what is projected count by using A. Now, it is a matter of application of a suitable interpolation formula, because I know I can go for extrapolation. I know 1, this, so I know x and f, x, f, x, f, I have to make f corresponding to x. Okay, so this is standard, or I can develop a model and do it. So, thank you for your very clear understanding and thinking about this problem. I will now leave it to you to figure out how one could implement an unequal probability sampling design. So far we talked about simple random sampling without. What if there is an unequal probability sampling design, assuming that the household size is available. In advance, I know for each of these households in the community, I know what is the household size. And we believe if the household size is larger, there is a more reason for the people to stay at home, because they cannot just go like that on weeknights. So, less is the chance of staying away from home if the household size is more. Okay? Away from home chance will be going down. So, there is a case for using PPS sampling. If I use PPS sampling, I come up with data, then how do I go for estimation of these numbers? Okay? A very interesting topic. To conclude, in this module, basically we talked about two major sources of non-response. One could be, as we discussed earlier, sensitive issues. Whenever we are dealing with sensitive issues, people are reluctant to divulge information. It could be because they feel that their privacy is being threatened, or it could be that they do not want to cooperate and they simply want to, they will simply refuse. Either it is a refusal or untruthful response, or simply not divulging the information because it is a sensitive issue. On the other hand, there is another reason for non-response. You make a phone call and the person is not available. These are called not at homes. If there is a situation of not at homes, earlier there was a question of recall, but then quite some time back there was a novel technique suggested by Hartley, followed by Pollage and Simmons, that you do not have to go for recall technique, but you can use an entirely different ingenious method of extracting information from the individuals who are just available on the day of the survey, and you can avoid this question of callback. So, that is the thing that we discussed today, and we picked up the Horvitz Simmons Pollage Simmons scheme, HPS scheme, and we discussed some issues regarding estimation of the numbers in different weeknights. It was a question of looking to presence of the people in the households in the weeknight surveys, and then we picked up the data analysis part, and also the question of estimating the incidence proportion of a qualitative feature capital A. That question also we picked up, and then we took some illustrative examples to discuss finer points regarding the computation. With that I end. Now we will pass on to exercises and MCQs. Thanks for your attention, Shubhro, and for your very good cooperation. Shubhro, can you start reading the questions now one by one?
Instead of random selection of the night of the survey, it was deliberately chosen as the third Wednesday of the month. Your survey was conducted as usual, with the results as indicated in the text for a total of n equals 1,000 households. The statistician was in doubt as to the use of the formulae and the validity of the results on estimates of the proportions. However, he was assured that his choice of the weeknight of the survey was not disclosed to any of the households. Immediately, the statistician felt relaxed and gave a nod to the data analysis. Did he make a fool of himself?
Okay, let's try to understand. It says that it was deliberately, instead of a random selection of the night of the survey, it was deliberately chosen as the third Wednesday of the month. The management decided to go for third Wednesday of the month, and accordingly survey was conducted, etc., etc. The statistician, he understands the theory, he knows that it has to be a randomly chosen weeknight, but it was not randomly chosen. So, he was debating whether he should do, etc. But the management is telling him it is okay, because people do not know that this third Wednesday of the month has been deliberately chosen. Okay, people have not been disclosed, they do not know. This is the day that we have chosen, we told them it is a random choice. So, how does it matter to you? Even though we have made a deliberate choice, but people, all the households, they know that it is a random choice. How does it matter to you? Okay. So, this is immediately the statistician felt relaxed. He gave a nod to the data analysis as it was being done. Did he make a fool of himself? Okay. Good question. Next one, please.
In Hartley-Pollitt-Simmons sampling scheme, the questions for extracting information are changed from "You are present tonight and please indicate how many additional weeknights you are at home" to "You are present tonight and please indicate the number of weeknights you are at home by putting a tick mark as per the following table." Exactly one evening, more than one evening, more than 2 evenings, more than 3 evenings, more than 4 evenings, or more than 5 evenings.
Okay. So, you have to put a tick mark on the appropriate answer. Okay. It is like cumulative, as you can see. Okay.
Develop appropriate formulae for the estimation of the pi tildes and illustrate the computations with an example.
It should not be difficult. Earlier you are asking how many, now you are asking cumulative, in terms of cumulative. Okay. Good question. What is the next one?
Instead of a random selection of the n households, suppose
IPS
IPS sampling is adopted. Subsequently, the same procedure of extracting information is followed. Can you develop formulae for unbiased estimation of the population proportions in different categories?
Let us try to understand. Earlier we said we are making a random selection of the households. First of all, we said all capital N households are taken into consideration 100%. Then we said we will go for a subset selection, random selection of small n households, and there we argued that we can apply two-stage formula E1, E2, V1, E2, E1, V2, etc. That is what we understood. That was also straightforward along the same line. Now they are saying make a subset selection of the households, but by adopting PIPS, suitable PIPS scheme, because you know the household sizes that can be used as auxiliary size measure, and if the conditions are satisfied, we can possibly go for a PIPS sampling scheme. If that has been done and you have followed the same procedure of extracting information, so that means whenever you have got the household selected according to the PIPS scheme, after that extracting data you follow the same rule. All those who are available ask whatever, 1 night, 2 nights, that way we are doing, okay, and you have the data. Can you develop formulae for unbiased estimation of the population proportions in different categories? That means P1, P2, P6, P0. What is the formula now, given that the households have been selected using PIPS method? It is a good challenging problem, okay, not difficult given the understanding that we have from all these chapters. What are the MCQs? Let us see. Let me read. Question 1. It may so happen that a huge percentage of the households may not be available on the night of the survey. That is what happened, 880%. Is this expected under normal circumstances? Yes, not at all, at times. Okay, under normal circumstances, is it expected that a huge number of households may not be available on the night of the survey? It was kind of, to us it was a shocking, my God, 800 out of 1000 are gone. Where is my data? That was kind of shocking to us. But is that normally expected or not? Second question, preliminary listing suggests that N0 star households are away from home for quite some time? It's an interesting question. I have made a preliminary listing. While doing that, I went door to door, knocked, and I tried to see if these households are listing I have to do. So that suggests that so many households are away from home for quite some time. People said they don't show up for months, they have left, they have this, etc. However, this information was not disclosed to the statistician, okay, who made a random selection of small n households from the entire population of capital N. To a statistician, you give the master list of capital N. He makes a random selection of small n households. He tells go and survey these people. But the agency knows that out of small n, how many are already not available. So that they put cross, and out of the remaining they go out. They carry out the statistical analysis as usual. Who made a random selection of n households from the entire population of capital N, carried out the statistical analysis as usual. Because if he makes a random selection of small n out of capital N, and if that incorporates already some members who are away from home anyway, that number will be 0, 0, 0. And he will be getting additional numbers who are not present tonight, but who are otherwise present sometime. Okay. Is it perfectly okay because the statistician is not aware of this fact? Or this analysis is not valid since a few of the n star, n0 star households are likely to be captured in the random sample, and we already know the status of these households. A separate analysis has to be carried out. Or the statistician became aware of this fact at a later stage. However, he decided to keep it to himself and went for usual data analysis as if nothing had happened. Usual analysis is not valid and nothing can be done at this late stage. The entire study has to be scrapped. That I think that should have been number D. Okay. So this should have been number D option. So number C option is right there. If nothing had happened, there should be an option number D. Usual analysis is not valid and nothing can be done at this late stage. The entire study has to be scrapped. Why is this late stage? Because small n households have already been selected out of the big master list, and that no-show people, that was not divulged to the statistician. Okay. So it says that the entire study has to be scrapped and one has to do it all over again. So please remember there is a D here, there are 4 options. Okay. Now let us see another question 3. Preliminary listing suggested that n star households are away from home for quite some time. However, this information was not disclosed to the statistician who made a random selection of small n households from the entire population to carried out the analysis. This analysis is not valid since a few of the n households are likely to be. Is this going to be the repeat of what we had earlier, or is it a different thing? Yeah, there must be something different here. Okay. The statistician became aware of this fact at a later stage. However, he decided to keep it to himself and went for etc. The entire study has to be scrapped. Okay. Usual analysis is not valid and nothing can be done at etc. The statistician became aware of this fact at a later stage. He quickly sorted out a revised and valid data analysis technique. The data from the entire study was gainfully utilized. Okay. Then you have to make choice, you have to tell which one is okay. These are the multiple choice questions. Is it possible that the statistician, once he is aware of this fact, he can quickly sort out a revised and valid data analysis technique? If you can do that, then you should be able to, before saying C is true, you should make sure that you know what the analysis is going to be. Okay. With this, I conclude my involvement in a series of lectures, video recording. Altogether 40 modules have been taken up, covering the broad topics of design of experiments and sample survey. We had 23 modules in the area of design of experiments and 17 modules in the area of survey sampling. And today we had the last module number 17. All through I have thoroughly enjoyed my involvement in this study. Thanks to Professor Bhaswati Ganguly, who initiated me in this study, who requested me to take up this part here, and also thanks to the entire team. Shantu Ghosh has been very instrumental to do all the LaTeX typing in proper formatting, and of course, I had Moumita Chatterjee, who impersonated as Sagorika Ghosh in the first part on design of experiments, and here I had Samapriya Basu, who impersonated as Subhro Shekhar Ghosh in the part on sample surveys. Thanks to all of you, and I do hope that the students and the participants, they will benefit from my deliberations on these two topics, which are very favorable to me. Thanks for your attention.